Hello, hello, hello. All right, let me confirm that we're live now. We definitely are. Cool. All right, so let's share my screen. Welcome, everybody, to the first workshop of AI for All. So I'm going to share my whole screen. And we're going to be building Sauron. And so if you guys want to follow along, I've got the Repl right here. I'll publish this. I'll publish it later, but if you can just fork this Repl, it is under repl.com/@Cody/Sauron. And so what are we going to do today? Yeah, so this is the first hackathon workshop that we're doing. And the reason why I wanted to do this is because we're going to be using Repl for the workshops. And there's a lot of really cool things that you can do with Repl specifically as it comes to Lightning development and AI. And I think that this is a really good way to start walking through some of the cool stuff you can do specifically on Repl. So what we're going to be doing is making a alternate backend for a Lightning node. And so if you guys have questions, just stop me as we're going through. But the way that Bitcoin works is that you've got this blockchain, which is a ton of information and data. It's like 500 gigabytes worth of information to store the total history of the Bitcoin blockchain, right? If you want to print it down to just like the present information and not all of the past information, so what's the current state of Bitcoin, then that's like 7 or 8 gigabytes, but it's all stuff that's like kind of bigger than you can just run in a normal Repl. So if I wanted to run a node on the like a Bitcoin mainnet node, that would be really hard to do because the Repl resources are, what does this one have? This one has, I can go boost. I get 0.5 vCPU and 0.5 gigabytes of RAM, right? So I can bump that up to like 16 vCPU, 16 gigabytes of RAM, and I have like 50 gigabytes of storage, but I can't run a full Bitcoin node inside of a Repl. And in order to use Lightning, which is a layer 2 on top of Bitcoin, I have to be able to talk to a Bitcoin node, right? And so what we're going to be building today is Sauron, which is a plugin for a node where we're basically going to unplug all of the things that are required for you to run a Lightning node that need a Bitcoin node on the back end. And instead of that, we're just going to route it to a public API, right? And so mempool is a block explorer, which has a public-facing API, which you can use to get all the information that you might need in order to run a Bitcoin node, right? So something that you might need is to get a block, right? So I'm looking up a specific block because I just saw a transaction where I'm opening a channel that pertains to that block. And so this is a way that I could get that block information just from the public API. And so why are we doing it this way? Is because for building AI and Lightning applications, there's been a lot of talk right now, and we've kind of gone over it a lot, of doing micropayments as sort of like the really obvious use case for Bitcoin and AI. But with Repl, you can spin up a core Lightning node. As long as you point it at a backend like mempool, then you don't have to, then you don't have to run the full node inside of the Repl. You can just run the Lightning node. And what's really cool about Repl is it's using this Nix backend so that you can get the core Lightning node through Nix and then use the plugins architecture of core Lightning in order to just like write your AI application or whatever it is that you're trying to program and have it plug into core Lightning, right? And so what do I mean by that? Is that if you normally wanted to install core Lightning on just like an Ubuntu system or something like that, you'd have to, let me open a shell. You'd have to go and do this whole process. But in order for me to set up a Lightning node inside of a REPL, all I have to do is add one line or two lines to my repl.nix file, which is packages.bitcoin and packages.corelightning. And what this does is it does a Nix build of Bitcoin and Core Lightning's binaries, hot loads them into the REPL, and it does it using Nix. And so it's a deterministic reproducible build every single time. And so I get Core Lightning out of the box. And so I can just go here, d dash daemon, Bitcoin d dash daemon dash reg test. So this would be starting a Bitcoin node in this REPL. And the way that did that is it hot loaded the binaries into this. And now that I have this Bitcoin node running on reg test, then I can do lightning d dash network equals reg test. There you go. And it like started, right? And so this is fine for if you're just using it on reg test, but how can we use this on mainnet? How can we use this with real coins, right? And so that's what we're going to be building today with Sauron, is that if I were to just try to start running a Lightning node, a Core Lightning node on mainnet right now, then I would do just lightning D. I can just pass that and start, right? Is that it says here, could not connect to Bitcoin D using Bitcoin CLI. Is Bitcoin D running? And so I could start Bitcoin D, but if I did that, then I would have to download a copy of the blockchain locally. And so like, that's a big problem because I can't fit the whole thing inside of this REPL. And the thing that I want to do is I want to build an AI application basically that like ties in LangChain to the Lightning node so that I can like read the log file, parse it out, and then pass it into GPT and then tell me why it's failing, for example. And so I don't want to have to run a full Bitcoin node inside of this REPL. But what I can do instead is that I can basically the way that Lightning, that Core Lightning works is using a plugin architecture where if I go over here and I just started this and then equals slash okay, that's okay. But so here's what we're ultimately going to end up building is we're going to ultimately end up building this. So we're going to build a plugin which unplugs the Bitcoin CLI, plugs in our Python program that does everything that the Bitcoin CLI would have done, and routes everything to a specific mempool endpoint, right? And so why are we doing this? Is because now that I have this, I can basically run a Lightning node inside of a REPL without having to have like the 500 gigabytes or the 8 gigabytes or whatever, which would normally be required in order to run a Lightning node, right? And so once I have that, well, then I can also take other things like LangChain applications, or I can make an embeddings database and like sell access to it, for example, like any sort of other AI application that I want to do once I have this primitive set up, right? So let's get started on that. So like what's important here is that when we start up Lightning D, it's going to start Sauron. Oh, sorry. Let me just get it all on. So let's go over here. Let's start working through the tutorial. So what is Sauron? So Sauron is a plugin that was originally written by DeRosier and Christian Decker as an alternate backend to the default Bitcoin CLI plugin. And so you can route all of the things that you would normally ask a Bitcoin node about, like what block, to like give me the information about this specific block, confirm for me whether or not this transaction has been included in a block, what is the current fee rate for, if I look at the mempool right now, so that in the event I publish a channel close, then I would be able to get included, all that sort of thing. It basically takes all of that and routes it to an esplora API. And so example we're using here was MutinyNet. So There we go. Cool. So now we're running, right? So it starts Sauron, which is this cool ASCII art. And now Sauron's going over here and it's checking all these blocks on MutinyNet, right? So I'm running a MutinyNet node here. And the only changes that I would have to do in order to have this run against a mainnet node, so I could use real Bitcoin for it, is that I would go into this run command. And instead of routing to the Mutiny signet, I would route to like a normal esplora, so on mainnet, right? So I can go to space/API, and I can do network equals. Sorry, I just don't need to pass that in, no way. Cool. Awesome. So here we go. We just connected to mainnet, and this is getting block information about the real Bitcoin blockchain. And now that we've got this running, I can do, I can hit against this node and I can do stuff like open channels. I can keep this running. I'm going to keep this mainnet node running after this. And just, like if you guys want to open channels with me, then that's good to go. So let's go over here. Let's actually build Sauron now. So if we go over here, the way that we start this, we don't have to explain Lightning right now. If you guys have questions about Lightning, I can address those. All right, so how does the plugins architecture work, right? So core Lightning plugins are executables that run as sub-processes of Lightning D. So Lightning D is the original binary that gets downloaded. So when we go into Repl and we go here and add packages.clightning, this is hot loading from their from their cache of Nix packages. This is hot loading that Lightning D binary into this Repl. And so a plugin is going to be a way that basically we can use this master process of Lightning D and give it child processes, which can talk to Lightning D and through Lightning D communicate with the other things going on, right? And so I can have this program that I'm writing run alongside my node and then get information from the node and like pull stuff out of it, right? So how does this normally work? Is that the plugin lifecycle is that the plugin launches and it's started by CLN in one of two ways, right? So it's at startup, so I run Lightning D, or dynamically at runtime, I can use lncli in order to start it up, right? So this is, if you see the way that we were doing this originally, is that this one we're doing at startup. I want you to use this data dir for your Lightning stuff. Log level debug. I want you to disable the Bitcoin CLI plugin that you would normally be using in order to talk to a Bitcoin node, and plug in the Sauron program that we're going to write. And then this Sauron API endpoint of this is an option that I'm passing to the plugin. I want you to hit mempool.space. Okay. Cool. So what's going on here is that Lightning D calls get manifest on the plugin. And so that basically just tells Lightning D, what does this thing do, right? So you can kind of think about this as sort of like a context window if you're coming from the AI side of that you're telling Lightning D, these are the capabilities and limitations of this plugin, right? This is how it needs to interact with everything else. And so here's an example of you like hit against a plugin for get manifest, and then it'll return like these are the things that it can do. These are the RPC methods. These are the events that it's subscribed to. So for this like hello world get manifest, every time that there's a connect or a disconnect event, then it will Lightning D will pass that event along to this program. And then it's got these two hooks, right? And that's saying that, hey, every time there's like an open channel, I want you to do, this is going to be doing something. And every time that there's an HTLC accepted, this program's also going to do something, right? And then it has these feature bits of like what capabilities and limitations it supports, basically like versioning of core Lightning. This is like another way that you can put this in, okay? So then once the Lightning D main process knows how to, like what the plugin does, then it calls the init method. And so it starts up the plugin. And so then it does all that. The plugin sends a success response, and there's like a timeout from when the success response should go. Okay. So what is BCLI? So BCLI is a plugin, is part of the like default plugins that come with Core Lightning. And so the things that it does are get chain info, get raw block by height, send raw transaction, get UTX out, and estimate fees. So these are all the things that a Core Lightning node needs to talk to a Bitcoin, like a mainnet Bitcoin node with the whole blockchain in order to get. So it needs to get chain info. So this is like current information about the blockchain. And so the example that we could use here, well, we'll get to that eventually. But so get chain info is just like a current snapshot of the blockchain of like, what's the current block height? How much work has there been? You know, that sort of thing. Get raw block by height. So this, I pass in the height of a block, and then that will return to me what the just like the raw block looks like, so that I can use that data and I can like look for transactions. I can confirm that something's been included. I can confirm that something's not been included, right? Send raw transaction. So when the Lightning node wants to send an on-chain transaction, then it'll go to the Bitcoin CLI, and through the Bitcoin CLI to the Bitcoin node. The Bitcoin node will broadcast that transaction, right? So that's something that we're going to have to intercept, and we're going to have to send to like a public esplora endpoint that allows you to send a raw transaction, and then get UTX out. So this gets the UTXO at the given transaction ID and output index. So this says I'm looking for a specific output, right? And so that might be a channel open or a channel close. And then estimate fees. And so the reason why you need to estimate fees, and so this is actually like a really tricky part of doing this. And like if you don't do it right, then like you can cause some issues for your Lightning node, because you can think about the Bitcoin blockchain as like that the Lightning nodes resolve back to. And so for a channel, there's two parties to a channel. And whenever there's a disagreement between the two of them on what the current fee rate is of like, oh, if I needed to close this channel, this is how much I would pay. But your channel party says, oh, that's way too low. You wouldn't be able to improve that transaction. Then they just close the channels, right? And so if your estimate fees method is not accurate and not something that your channel parties are going to agree with you approximately, then they'll just like default to closing the channel. And so you got to make sure that this is good. And, you know, we're going to be using the mempool.space Explorer API. And so like our estimate fees can be pretty good because, you know, the mempool is like their mempool is very, very good. Basically what everybody uses. And so in order to swap the BCLI plugin out for our Explorer plugin, we'll have to intercept these wire calls in the specific format that the Lightning D expects, and return a wire call in the expected format. And so basically from the Lightning D's perspective, what we have to do is make sure that if we're going to unplug Bitcoin CLI, there's a bunch of other plugins that are like core to the Lightning node that rely on BCLI like doing things in a certain way. And so if we're going to replace BCLI, then we have to make sure that we're doing things the same way that does, so we don't have to go configure anything else in the node, right? Okay. So here are like the complete list of functions that we're going to be doing. So we're going to need like a fetch method so that we can go hit against the public API. We're going to need the plugin setup methods. And so like we said, is that we need this init method in order to, for Lightning D to be able to start the plugin. Then these are the different plugin methods that we're going to need. We're going to need get chain info, and chain info, it takes in the plugin object and some keyword arguments, and it returns a dictionary with the following keys. And so this is the same way that Bitcoin CLI would return it. And so when we write get chain info, we're going to have to return it in exactly the same way, right? And so that's like, this is the chain that we're using. So like mainnet, testnet, regtest, signet, mutinynet, or whatever. The block count, so that's like what the current height is. Sorry, the block count is, yeah, we went to the difference between these two. But basically, block count is how big is the blockchain. How much have I confirmed up to? Head account is just what is like the total size of the number of headers, because the blockchain is actually just like a chain of the headers. And then initial block download is whether or not the node that you're using is in the state of initial block download. Because if it is, then it can't give you all of the block data that it hasn't verified yet, right? We're going to be using esplora, and we're going to be using the mempool API. And so initial block download is just always going to be done, right? So it's not an initial block download. So we're going to set this to false. Then get raw block by height is going to take in the height that we're going to take, the height for the block that we're looking for. And it returns that block hash and the raw block in hex format. Send raw transaction is going to be takes the transaction, and then it returns a dictionary, just like whether or not the transaction was submitted successfully, right? And then get UTX out is get the UTX out the given transaction ID. So we pass in a transaction ID and a vector output. And so basically if you guys haven't seen this before, because I know some people are new to Bitcoin here, is that you can describe any output of Bitcoin based off of the transaction. So a transaction has many inputs and many outputs potentially. And so you can say this transaction ID, the output at this index, right? So let's not use a Coinbase transaction. Let's use something like this, right? So the way that I would describe this specific out point would be this transaction ID and V out equals 0, 1, 2. So it'd be TXID equals this, V out equals 2. And so that would go TXID equals that, and then V out equals 2, the output index of it, right? And so it returns the amount and the script pub key. And so we don't have to get into this too much, right? But the amount is just how big is this thing of Bitcoin that we put there. And then the script is what are the locking conditions of that Bitcoin, right? And so if I wanted to spend that Bitcoin, I would have to satisfy this locking condition, right? And what the Lightning node is doing here is that it's saying that, hey, I want to confirm that this transaction exists and that the script and the amount are what I expect it to be, right? Because if it's mine, then I need to know that the script that this thing locked to is something that I know how to unlock, right? Because then it belongs to me. And then estimate fees, right? So estimate fees for various Lightning transactions. It returns opening, mutual close, unilateral close, and delayed to us HTLC resolution and penalty. All of these are just different fee rates, right? So these are different actions that the Lightning node might want to take. And this is saying if you wanted to include this transaction and get it included in a block, if you wanted to broadcast a transaction and get it included in a block soon in order to do a unilateral close, this is the estimated fee rate that you would have to pay, right? So if we go look at mempool right now, here, in order to get included in the next block, you'd have to pay approximately 16 Satoshis. If you want to get included in any of the following blocks, it would be approximately 5 Satoshis. And this might go up a little bit. So once this gets confirmed, then normally this number goes up as well, right? So here, that's that. And so let's actually start building this thing, right? So I'm going to go in here and I'm going to use inside of Sauron, I'm going to do new sauron.py. And so in here, we're going to start building it. Keep following this tutorial too. Okay. So here's like just a helper method for fetch, right? Of that, this is just going to be how we hit against the API, right? And then for this, we have to import, there's a couple of imports that we need here. Jar. I will just copy these over to start with. There we go. All right, and the Sauron eye is just the art thing from there, and then we'll be using these later. Okay, so that's like our fetch method, right? So we're going to use this fetch method in order to hit against the esplora API at mempool.space. Cool. So the init method, right? So when we were going over how to do this of that. Let me just copy this over so that we can read it. So if we go here, it's going to be our init method. This is the first thing that the plugin is going to call. That the Lightning D is going to call. It's going to say like set up this plugin and start it. Okay, and so this is going to take, we need to find out. There we go. So this is going to take a couple options, and the specific configuration options that we're going to be setting are what the API endpoint is. So this is where we're going to be hitting against. And then this is going to say like, oh, if there's no API endpoint, well, you need to specify an API endpoint. And then this also lets you do a Tor proxy. And so like Sauron, you're trusting somebody else. If it's not your node, you're trusting somebody else's for this one. And so this just allows you to go through Tor proxy. But just in general, is that if you're using Sauron, you're just trusting whatever API that you're hitting against, right? So if it's not your node, it's somebody else's. But yeah, so there we go. So that's our init method over here. So let's actually get to the implementations, right? So get chain info. So this is the first one that we're going to be doing. So let's copy this over and then think about how we're going to do this. So for get chain info doesn't, it has the option of taking additional arguments, but everything for every method within a Core Lightning plugin has the option of taking additional arguments. The thing that it's returning is what's the chain, what's the block count, what's the header count, and whether or not initial block download is continuing, right? And so initial block download is always going to be false because we're hitting against a API over here that's like, got it. But we can go look at this API and go figure out how can we get this information, right? So let's hit here, and then we can go down and go find where's the blockchain data for this one. Let's think about this. So if we go down here where I implemented it, right, is that the chain that we're returning here is identified by the known Genesis block. And so what does that mean? Is that the way that Bitcoin works is based off the heaviest work chain building off of an established Genesis block. And so the first block that you build off of, the thing that doesn't have anything before it, that's just like an arbitrarily set thing, right? And so for this one, this was the mainnet block that Satoshi mined, is that he put like a message in the Coinbase over here, but he could have set this to anything that he wanted. The valid Bitcoin chain is the one with the most proof of work that builds off of this specific block. And so for mainnet Bitcoin, this is just like a hard-coded number. And so for identifying the chain, the way that you normally do that is you hit against the node or whatever it is that you're asking for, and you ask it for block 0. And then based off the block that it returns, then you can determine, is this mainnet, or is this signet, or is this testnet, or is this whatever, right? And so for here, the options that we're going to support here are mainnet, testnet, signet, and regtest, right? And all of these are just hard-coded blocks. And so what that's going to look like is this. So for here, we've got, this is just the block hashes for the networks. And so this is mainnet. So if I go over here, 0000019D668. So if I go check on this one, copy this, go look over here. That's the same block. Okay. And so that's the mainnet block. And then if I go to here and change it to testnet, because I might want to use testnet instead, we'll notice that the block hash is different. And so for this one, it's going to be, this is testnet, right? It's different than the mainnet chain. And so the heaviest work chain building off of this one specifically is the valid Bitcoin blockchain, right? For testnet. And then same thing for signet, same thing for regtest. Cool. So when our Core Lightning node asks us to get the blockchain info, it's asking what network it's running on. And we can get that info by getting the Genesis block for the esplora API. We configure our plugin. So the way we're going to do this is that we're just going to fetch and get we're just going to fetch and get the block at block 0, right? And then this is just error handling around that. And then it sets the Sauron network to what the chain is. So block count header count and initial block download is just get the chain tip, right? And so why is that? So we figured out what chain we're running on, and now we want to figure out how long is that chain and how much work has there been done on it, right? And so the header count during initial block download. So when the node is initially getting data, it'll start from 0 and go all the way up to the present day. And it'll just like go through and validate that data. And so if initial block download is true, the header count will go all the way up to the chain tip, because in order for you to verify the Bitcoin blockchain's headers, all you have to do is just continue along hashing them, right? But the block count is all of the data inside of the block. And that one takes a lot longer to validate, because you have to validate all of the signatures from all of the transactions inside of it. And so when you first hit against a node and you ask for, hey, what's like the header count? So how heavy was the work on this chain? How long is this chain? And then what is your block count of how much of this chain have you verified? And if there's a difference between these two, I can use header count to figure out whether or not I'm on the correct chain. And I can use block count to figure out whether or not I can ask this node for certain data, right? Because if it hasn't gotten up to the data that it hasn't verified, then it won't be able to answer my questions. And so the way that we're going to get this is that we're just going to pass in, here we go. So we're going to hit the esplora API again, and we're just going to get the chain tip, right? And so what does that look like? If I go over here, I'm still running. I'll just send the curl request instead. Curl https space /pi/ block /tip/ there we go. Right. So this just gives me the current block height, right? And so because I'm hitting against this public node, I know that it's synced up all the way to the top. So I'm trusting them to do that, but like it's the esplora API through mempool. So they are synced to the very top. So this gives me block height and header count is what I'm going to set this one to, right? And then if I wanted to get chain, remember the way they said we're going to do that is we're going to hit against block height 0. Sorry, block height. There we go. And this gives me the hash. And so this hash is the one that we compare. So I got this back. This is the Genesis block for this chain that I was asking about. And it gave me 19. And so if I did that same thing and did it to mutinynet.com, which is a signet, all signets have the same Genesis block here. And so I should expect this to return this number when I return it. There you go. 0000881987. 881987. There you go. Cool. All right. So that's working. And so when we do get chain info, then it's going to get the what chain it's on. It's going to get where's the second call that it does? Sorry, this is normal Sauron. New Sauron. It's going to get what chain it's on, and it's going to get what the current block height and chain and header height is. Right. All right. So, and then the IBD we're just going to set to false. Right. And the reason why we're just setting this to false is because we're trusting the API that we're hitting against. Again, this is like not you verifying your own node, it's you trusting whatever API you're hitting against. And so you're trusting them to be synced up to the current chain tip. Okay. Cool. So get raw block by height. This is the next method that we're going to implement. And so this method is, copy this over. This is going to be that my node needs to get information about a specific Bitcoin block, right? So it might be trying to look for a transaction inside that block, or it might try to verify that a transaction is not included in that block, for example, right? And the way that that gets returned is that it's going to give back a block hash and the block, right? And so the reason we're doing that is for like a Merkle proof, probably is the way it's going to be doing this. But yeah, that's the thing that we need to get. And so how can we get that information? Well, if we go to the esplora API that we're using over here, then I can get block, which will probably be useful. And that's get block by hash over here. So I'd have to pass in the hash in order to do it. But this one says get raw block by height. And so that's not going to be the way that I get that. I see there's a get block hash raw, that one. Is there block height? Okay. This one, yeah, so here we go, is that if I can use this endpoint, which is get a block by height, and it will return the hash. And then I can use this hash for another call to get the block. Does that make sense? So I can go over here. I think I've already implemented it down here. And so this is going to be get the block hash by the block height, and then get the raw block by the block hash in order to get this information. So we got this in here. And what this looks like is we get the block height. Sorry, we get the hash based off this block height, and that'll return that. And so if it fails, then I just return none. And then we use that block hash response in order to get the raw block data. And so then if that works, so this does a retry loop just in case it doesn't give me all the block data back. But I pass back, so if it fails, then I pass back none. But if I get it all back, then I give back the block hash and the block data right there, right? And so that works. That implements what we need it to. So the next part of this is send raw transaction. And so send raw transaction is that my node needs to broadcast a transaction because it's either trying to open a channel or close a channel, right? Or it might be trying to do just like a very regular on-chain transaction in some way. And so what's nice is that esplora has I think it's the single post request inside of here, is that it has an endpoint for posting a transaction. You just hit API/TX and you give the transaction data that you're trying to submit, right? And so we should be able to go in here with our send raw transaction. And implement it like this. So we hit the plugin endpoint, TX request with the transaction as data. And so if we go over here, we see send raw TX as the raw TX right there. I think this might actually be an error because raw TX. Yeah. And then either it returns success or it returns failure, right? And so just like we said from Bitcoin CLI is that if it's success is false, then it returns the error message. Otherwise, it returns success true error message. And if we go back to the BCLI plugin, we know that it expects, it passes in this TX. Well, let's just call it TX here. Yeah, it returns a dictionary with success and error message, and just true or false for the success and an error message if it exists. Okay, so back to where we're going. Table of contents. Get UTX out. So for UTX out, this is looking up for a specific transaction. And so that's going to look like is here. This is a plugin.method UTX out. Pretty sure that's correct. Let me just verify. Cool. So how do we do this here? Is that I need to be able to look up a specific transaction based off the ID and the output index. And so if I go to mempool, then I need to be able to get a transaction. And so get transaction. So then So I can get the transaction off this one, and then this transaction will return this. And inside of here, I can look up the V out, right? So that'll just be a single call, and that'll return the V out there. And then I'll also have to return some status information about it, of whether or not the transaction's been included in a block and which block it was included in, right? So if we go back over here, oh wait, I don't have to return that. Never mind. That's okay. So here's the way we're going to do it, is that we're just going to hit against TXID. So we're looking at based off the TXID there. And so that'll return this thing, right? And inside of here, it'll have a vector of inputs and a vector of outputs. And so, for example, I can use this and just curl against it and find a transaction. Should be here, TX. Sorry, let's go just find a transaction. On mainnet. Okay, so I should be able to find this, and that should have like a big vector of outputs. So let me copy this transaction ID and then go look this up. Transaction not found because I'm hitting against testnet. So get rid of this. API. Endpoint does not exist. It's the endpoint here. Get transaction API slash API slash TX slash TXID. That's because I made a mistake here. So that's the one I want to hit. Pull dot space slash API slash TX. Okay, I think we're having an issue here. It looks like a. Let me try this on initial. Copy this correctly. Let's try this one. Why am I getting this error? Oh, okay. Well, here's one. Well, I should be doing outspend over here. Sorry, yeah, that was a digression. So over here, getting the transaction by transaction ID, right? So we get the raw transaction from mempool where we just hit it against TX slash TXID. So let me just confirm that I'm getting this correctly. That I did get TX URL and status URL. And then I hit against both of these things. And then we're good. Yes. Okay, cool. Right. So here's like the other element of it that we're looking for is that we want to make sure that the specific V out that we're spending hasn't been spent yet. Right. And so just having the transaction that we get. So we hit against a block, we hit against mempool, it returns it back and says, yes, this transaction was included a block like 50 blocks ago or something. Well, the problem is that there could have been a follow-on transaction that spent that, right? And so this is why we want to make sure that we look up this out point and the status of it, right? We want to make sure that it hasn't been spent. So for anyone new to Bitcoin, the way that this works is that you have transactions, and transactions have inputs and outputs. And those outputs can be used in follow-on transactions as inputs. And that's how you maintain the supply cap, right? Is that like you always can trace the Bitcoin to where it was created, like where it initially came from, right? Like it gets probabilistic for those ones, but like you always know that there's the supply cap has been maintained. And so for this transaction was included in block 797165. And over here, it had one input and two outputs. This transaction, this output was then used as an input in a later transaction. This one has not been. And so I could go look this up and go see where this was spent. And so it had an input. So I'm looking for 0.02852 from here. There we go. So this guy, this address had one transaction that came in with two outputs, one of which went to this address. He then used this input as an output here. And so if I just went and looked up this transaction, I wouldn't know whether or not this transaction, like the outputs of the transaction were still valid, whether or not I still had Bitcoin, or whether or not the person I'm trying to open a channel with like actually funded the channel that they said they would, right? I have to get the status of this out point. And so what I'm going to do that is I'm going to hit against this outspend endpoint, which is, if we go over here, the API, I have to do this for, never mind, ignore this part. We don't have to cover that. So this is when you're hitting against the Blockstream API, right? That's okay. So we scroll down here, we get whether or not it's been spent, right? We say, if it has been spent, we just return none, right? So it's like, oh, hey, that transaction you looked up was invalid. But if it has not been spent, then we return, this is the amount that's currently there, and this is the locking script in order to access it, right? Cool. So then the last thing that we have to do for fully replacing the Bitcoin CLI plugin with Sauron is getting estimate fees, right? And estimate fees is because I need to know whether or not I can include a transaction, like I can get a transaction included in a not crazy period of time, right? So I might need next block, or I might need 10 blocks from now, or I might need like 100 blocks from now or something like that. But the way that Lightning works is that when you resolve back to the Bitcoin base layer as like the court system, is that you have a certain time period that you're able to do that in before your channel party might be able to like sweep their funds out, and then you wouldn't be able to get them back. And so if you had a disagreement and he was cheating or something, right? And so estimate fees is, how can I make sure that my transaction gets seen and included inside of a block in like during that period when I can get my funds back, right? So the way that we're going to do that is we hit against, so mempool and Blockstream do this differently, is that when you go to mempool, the API here, they have an endpoint for estimate fees, which is fees, fee rate, fees, mempool blocks fees, get recommended fees. Yeah, so these are the two endpoints that you can get. So you can hit against recommended fees, and that'll give you fastest, half hour, hour, economy, and minimum. Or you can hit against this one, get mempool blocks fees. And so this will tell you, that just tells you the fee. Yeah. So this tells you like the current state of the mempool, right? And you can use that to infer what the fee range is in order for you to get included in the next block. Okay, so the one that we're going to use is this one. It's like recommended fees. Right, so if we go over here and then go to our new Sauron, let me just copy over my working code for this one. Oops, sorry. Then I get estimate fees, which is going to be the last component of this. All right. This has to return opening rates, mutual close, unilateral close, delayed to us. And so these don't perfectly match up against what I get returned over here, but you can basically think about them as kind of the same concepts, right? Which is that for an opening transaction, right? Like, you know, I might want to get it included like right now, or I might not really care when it gets included, right? Because I might be using like a zero conf channel or something like that. And so I don't necessarily care that it gets included in the next block. It has to be included just soon. Like a mutual close fee. This is like my channel parties collaborating with me. And so we might like negotiate the fee down to like a low enough rate that like both of us are satisfied with it and we're not paying too much. And it's like, okay, it's okay if it takes a little while. If we're doing a unilateral close, right? So it's I'm just manually closing it myself without talking to them, then I want to get it included like a little bit faster. If I want to do an HTLC resolution or like a penalty, right? Then these are ones that I want to get included like in the next block, right? So the way that I'm going to assign those is based off of like the fastest fees are going to like the penalties, transactions, those kinds of things. So if we go over here, we can copy this over and then we can put this down here. And change this so the penalty is like half an hour. Or, well, you don't need to necessarily. This is okay. It works. And so this says like min acceptable and max acceptable. And this is what you're negotiating with your channel party on behalf of, right? And so here we go. We just re-implemented new Sauron over here. And so let me just confirm that we're not missing anything. I think we are. We have to have plugin.run at the bottom. That's like the script, right? So not that one. Run. So this should work now. And so I'm going to go over here. I'm going to change to this one. Instead of using Sauron, I'm going to use new Sauron. And that's going to be running as mainnet. And so this has been running for a bit. Right. And you can see that it's basically synced up to where it needs to be. And now it's just like every once in a while for gossip and stuff. It's looking for what the current fee rate is. Right. So I can do stop, clear, and we're going to start it again. And this one's going to run new Sauron that we just built. Okay. So why did this not do this? Permission denied. I think I have to make it an executable, do I? So ls cd on okay, so here we go. We got a error. I think that's where I copied over the thing incorrectly. So if I go to line 92, I'm missing. And then I'm missing a comma. If not, blackout res. Did I not copy that over correctly? So this is where I have it working. Oh, and I got to add these options at the bottom too. All right, so these are the two plugin options. Right, so you say whether or not, you say what endpoint you want and whether or not you want to use a Tor proxy. So just get chain info. Yeah, I think I didn't copy these over. info. Yeah, I'm missing this. And I'm missing. Oh, okay. This was just my mistake. I have to go here and go back to table of contents, get chain info. I changed the naming on this. That's okay. I'm just gonna pull this one over. This one, raw block URL. I hit raw block rec. I called it raw block. SendTX. Yes, and I can ignore that because I don't need to use it. Fetch fee rate URL. Spacing. This one goes here. Fee rate rec. Oh, some naming. All right, that should work. Sweet. Oh, there we go. Why did this? There. Bad response to estimate fees. Bad result field. Response was estimate fees. Error. Error while processing estimate fees. No active exception to re-raise. Okay, so I think I need to do some error handling around the fee rate that I have there. But for right now, just because we're coming up on the hour, I'm just going to copy this one over that I know works. And then we're going to talk for a second about making your own plugin. Processing get raw block by height. Bad results. String get raw block by height. Okay. Again, not going to debug this because we have to finish up soon. But raw block. Okay. Run. Okay. There we go. It's working. Probably because I just copied over my working code for it, but no, didn't want to debug for those live. Okay, cool. So this is kind of like a good overview of the plugins architecture for it and how you can take your program and plug it into a core Lightning node, right? And so why did we go through this whole process of writing a plugin for this is because one of the things that you might want to do as part of this hackathon is take like AI and plug it into an actual Lightning node. And this is a really effective way of doing that, right? And so what we're going to be announcing later after this is a couple of Repl bounties And one of the Repl bounties is going to be for doing core lightning plugins help me. And so this would just be like a quick project that you can just kind of get running. There's this really cool help me plugin that I think Rusty wrote. It's also written in Python, and this one basically gives you a bunch of information and stuff on how to like run your node more effectively, right? So it tells you that like you need active channels, it recognizes problems with the node and all this kind of thing. The thing that we'd like to see is somebody to make a plugin like Help Me that uses AI behind it. And so you can take snapshots of the current node, you can use the logs, you can get information off of the node in different ways, the kind of same that way that Help Me does, right? And take that, pass it into a large language model in order to get it to help you with what you're trying to accomplish, and then have it spit back recommendations of like what the user is trying to do, right? So you might want to do a plugin called like, Help GPT or like Help AI. And so you would be able to interact with that through the node for that one. And so we'll be announcing a Repl bounty for that next, but this should give you a good walkthrough of how to write plugins and some ideas on how you might want to tie in AI in order to do that. So yeah, I think, are there any questions or comments? I've seen a couple. Sorry, I should have checked these more.
No worries, no worries. Hey, Cody. Yeah, I'm here. Sorry, I jumped in a bit late, but yeah, I was on the chat for a little bit. No, we didn't get any questions now, but really interesting what you've done there. And yeah, this plugin system of Core Lightning is it's pretty expressive. I'm super excited to see what people come up with.
Yeah, and it works really well with Repl, right? Because you're loading the Core Lightning binary in, and you don't have to make any changes to that. Like all the complexity behind that's already gone away, and so you can take your just kind of like more simple or more specific plugin and only write that part and focus on that part. And like the rest of it is just kind of handled on its own.
Yeah, definitely. Like what would the process be for like claiming the bounty? Can you mention?
Yeah, so I'll be posting the Repl bounty for it. So it's going to be up on the Repl bounty system for it. And yeah, like, so as you do it, like we'll probably do it just for a couple days or whatever. And it's just going to be like, whoever, just make an MVP with it, just hack in LangChain or hack in OpenAI calls or hack in like a locally run model, or just like take the Core Lightning documentation, making vector embeddings over it, and load that in. It's just like using AI as part of like a Core Lightning plugin in order to help someone using the Lightning CLI to like accomplish things they want, right? So I'm using the Lightning CLI. I'm not entirely certain how to do it. Can you use like training it or just using embeddings over the Core Lightning documentation and some other things related to Core Lightning in order to help the user figure out what they were trying to do, right? And you can also use this. I think that that definitely qualify for like the Bitcoin education track that we're doing, right? Of like a command line helper for a Lightning node. So.
All right. Well, amazing workshop, Cody. I want to encourage anyone watching to also register if you haven't as yet. Everything here is recorded, and we'll be sharing it and hopefully clipping it up soon because there's some gems in here as usual. Anytime Cody talks, but. Yeah, should we end it there?
Yep, it's good to go.
All right.
Thanks, John.
Cheers. Happy hacking.